All right, today we're looking at acid and base under the Bronsted-Lowry acid. I'm going to start with the definitions and then we'll do some practical work on that.
According to Bronsted-Lowry, an acid is a proton donor and a base is a proton acceptor. Therefore, in an acid-base reaction, a proton is transferred from an acid to a base. For example, in this reaction, HCl is an acid, H2O is a base, H3O plus is the conjugate acid. Conjugate acid, the species formed when a proton is added to a base, is called the conjugate acid. Cl- is the conjugate base. Conjugate base, the species formed when a proton is removed from an acid, is called the conjugate base.
All right, let me explain briefly here. What is happening here is that when you look at HCl and H2O, according to Bronsted-Lowry acid, definition, an acid is a proton donor. What is a proton? And why do we call it a proton? Anybody? What is a proton? Any response? What is a proton in this case? All right, when you look at okay, I have a response. What's that? A positively charged particle. Yeah, you have an idea, but in this case, when you talk of acid and base, we don't look at it that way. We're looking at the composition of an atom. But this time around, we're looking at acid and base. So let me explain that. Okay, somebody has another, a cation. Well, you're also right, but this definition is different. When you talk of proton in acid base, let's look at hydrogen. Another response. Let me see what that person says. The stability of an atom. Okay. All right. Let's just hold on. All right. When you have an hydrogen, how many proton, how many other electron has hydrogen? Hydrogen is 1 and 1, right? One. Hydrogen has 1 proton, 1 neutron. Sorry, 0 neutron. Doesn't have a neutron. 0 neutron and 1 electron, right? That is hydrogen. That is the properties of hydrogen. 1 proton, 1 electron, and no neutron. So that is 1/1. That is the normal hydrogen gas. If this hydrogen loses an electron, it becomes what? Becomes a plus charge, right? It loses 1 electron, becomes a plus charge, and that is a cation. You're right, cation, a positive charge electron or a positive charge ion. So this hydrogen ion has lost 1 electron out of all the properties it has. So what is left in the hydrogen? When that electron is gone, what is left in hydrogen property?
1 proton?
1 proton, excellent. That is why it is called a proton. A proton is a positive charge hydrogen, because the only properties the hydrogen has is 1 proton, 1 electron. And if 1 electron is given out, it has no more electron again. The only thing it has is proton. So that is why a positive charge hydrogen is called a proton. Just in case you come across it anyway again, I'll ask you a proton. A proton is the same thing as, in this case, is hydrogen plus, that is hydrogen ion. So that is why in definition of an acid here, they said is a proton donor. That means it donates a positive charge. That is why you see it here, a positive electron, a positive hydrogen. That is a proton, all right? So If HCl donates a proton, or because according to the definition of an acid from Bronsted-Lowry, he said an acid is a proton donor. So if this HCl donates a proton, that is H plus, is gone to H2O, what you have left is just, it left behind H, right? I mean Cl, sorry, left behind Cl, because the H is gone to H2O. H2O here accepts the proton, right? So this is the acid because it is the substance that donates a proton. This is the base because it is substance that accepts the proton. So according to the Bronsted-Lowry acid definition of acid and base, an acid is a proton donor, a base is a proton acceptor. So HCl here is an acid because it donates a proton. H2O here is a base because it accepts a proton. Now, what next? What is left behind when that happens is what you call the conjugate base. So Cl is your conjugate base, while this is your conjugate acid. What you get when a hydrogen proton is taken away from HCl, what you have behind is your HCl, which is called the conjugate base. Just like acid, conjugate base. Base, conjugate acid. You can see those. So acid and base, conjugate, let me clear this. Acid and base. So this is an acid, this is the base. So what you get when H2O accept a proton is H2O3 plus, because one positive is added to the H2O. Remember, H2O is neutral, is zero. So when you add plus one to it, becomes plus. All right, so that's how you got H3O plus. And this is called a conjugate acid. And then this is called a conjugate base because you are taking away the proton that is making it to be acid. So this is a conjugate acid, conjugate base. This is your acid and this is your base. Any question on this? So a conjugate acid is a species formed when a proton is added to a base, which is called a conjugate acid. That is this, H3O plus. A conjugate base is a species formed when a proton is removed from an acid, and that is called a conjugate base. Any question on that? Okay, let's continue.
The conjugate acid-base pair consists of two substances related to each other by the donation and acceptance of a single proton. Example: in the following aqueous reaction, identify the acid, the base, the conjugate acid, and the conjugate base. Looking at the equation, one can conclude that H2O has accepted a proton from HONH3+ to form H3O+. Thus, HONH3+ is a proton donor, the acid. H2O is the proton acceptor, the base. H3O+ is the species formed when the proton is added to the base, the conjugate acid. HONH2 is the species formed when a proton is removed from the acid, the conjugate base. Example: in the following aqueous reaction, identify the acid, the base, the conjugate acid, and the conjugate base. Looking at the equation, is HClO a proton donor or a proton acceptor?
All right, that's the question for you. It's HClO, a proton donor or a proton acceptor. I would prefer you speak out because this is a recorded something, so that because the text would not be showing in the recording. Unmute your mic and speak out.
Donor.
A donor, okay. Somebody said it's donor. Why do you say a donor?
Well, I see that in the product. It gave up hydrogen.
Exactly. It gave up the hydrogen. So ACO, ClO minus is left behind.
A
It's a donor.
proton donor
Okay.
is
If
defined as
yes, what is the definition? What is this? Bolang?
As an acid?
Acid, okay.
C6H5NH2 a proton donor or a proton acceptor?
Yes, response.
It's an acceptor.
It's an acceptor, very good, because you can see that it has increased by plus here. That means one hydrogen has been added. Acceptor. All right, so that is also a proton acceptor is defined as a base. All right, ClO minus is the specific form when the blank is dashed from the blank. Who can feel that?
So CO2 is the species form when protons is donated from the acid.
Okay, proton is donated from the acid. What is the acid?
The acid is HClO.
Okay,
Thus,
proton
is
is removed
ClO
from the acid.
minus a conjugate acid or conjugate base?
All right, is ClO minus a conjugate acid or conjugate base? ClO minus, is it conjugate acid or conjugate base?
Conjugate base.
Conjugate base. All right. So C6H5NH plus is the specific form when the blank is blank to the blank. Yes, you can feel that.
C6H5NH3 plus is the species formed when the proton is added to the base.
Okay, very good. When the proton is
Thus,
added to the
is
base.
C6H5NH3 plus a conjugate acid or conjugate base?
Conjugate acid.
Conjugate acid. Thank you. All right. So that is all we want to learn about Bronsted-Lowry acid. So you should be able to identify acid, base, conjugate base once you have equation like that. Now, remember, I think it was regular class when I said water is an acid. And some of said, maybe, was it this class that we're talking about water and an acid? I think it was in regular class. Okay, so some cases will arise where they will give you water that will be acting as an acid. Because once you see that H2O becomes OH, that means it has donated a proton. So in that case, it's acting as an acid. All right? So take note of that. Okay, let me see. I think I want to add more to this recording. So this is another PowerPoint. What we want to add to that. So in this case, you have HCl as an acid donating a proton to H2O, just like we've seen in that video presentation. So the acid, and this is the base, and this is the conjugate, base conjugate acid. So H2O, H3O plus is a conjugate acid. All right. Now, these are the properties I want to talk about briefly. Strong acid are assumed to be 100% ionized in solution. That means they are good hydrogen ion donors. Strong acids. So I'm going to list the strong acid for you. We have HCl, H2SO4, and HNO3. These are the strong acid, common strong acid in the lab. Weak acid are usually less than 5% ionized. What do you mean by 5% ionized? Now, what do you mean by 100% ionized? This means that when they break up, let's say you have HCl, aqueous, ionizing. This way you have H plus and Cl minus. This is 100% ionized. That means all this HCl broke apart into hydrogen ion and chloride ion, 100%. None is left behind. That is what you call complete ionization, 100% ionized. Okay, now when we say something is partially ionized, like 5% ionized, let's say, let me use an example here, like H3PO4 or H2C, this is a carbonic acid. So that means that when this is in solution, let me use this C2, which is a vinegar, which is common ones, ethanoic acid. When this one ionizes, it's not completely 100% ionized. So you have about just partially H plus and C2H3O2 minus. That means only 5% of this is ionized. You still have 95% of this acid still together. That is what it means, because it's a weak acid. Only 5% breaks down into hydrogen ion and ethanoic ion. The rest, 95%, are still together as an acid, as an aqueous right here. Unlike HCl, that everything is broken down into H plus Cl. So it's like if you have 100 ml of HCl, ionized 100 ml of H plus and Cl minus will be produced. So if you have 100 ml of this in solution, only 5% will be here. The remaining 95% will still be together as ethanoic acid. That is what we mean by weak acid and strong acid. 100% ionized and 5% ionized. Is that clear? So these are the weak acid that we have in the lab. All right. They are also the organic acids. They are all weak acid. They are poor hydrogen ion donors. All right. So sodium hydroxide is a strong base. These are hydrogen ion acceptor. So these are the strong base in the lab. We have sodium hydroxide, potassium hydroxide, magnesium hydroxide, and calcium hydroxide. So this is a base. The presence of OH is a base. All right. When OH is present in a compound, that means that is a base. All right. In base combines with H plus in what acid to form water. So example is, if this is a base, this is an acid, you can see from there, the HNO3 donates a proton to H2O, so that this is your acid, because this hydrogen is now given to H2O and then forms H3O plus. That's a conjugate acid, and what is left behind on this acid is a conjugate base. And this is the diagram when you're asked to draw a diagram of such. So this is what you draw. All right. All right, this is a nice situation where water is an acid in this case. Look at this. Look at this situation because in this case, water is H2O, donates a proton to ammonia and becomes OH minus, which is conjugate base. So this, in this equation, this reaction, H2O is acting as an acid. That's what I was saying. That sometimes water can be an acid, so don't be confused. That is, we're using it as a base, but this time around is an acid, right? That is the diagram for that. And then water is, you have seen that we're able to use water in two different ways, as an acid, as a base as well. So this type of oxide or compound is called amphoteric because it can act as base as well as an acid in different situations. So this is called amphoteric oxide because water is an oxide. H2O is an oxide. So amphoteric can be an acid or a base. So water is an example of an amphoteric substance because it can act as a base. You can see here it's acting as an acid. In previous example, it was acting as a base. All right, so don't let me take too much of your time here. Give the conjugate base for each of the following. What is the conjugate base for HF? Yes, quickly. Conjugate base for HF.
F minus.
F minus, thank you. Conjugate base for H3PO4. Somebody else?
PO4.
Mm. Mm. Remember, we are donating a proton, not protons. We are donating a proton.
Oh, so H2PO4
H2PO4 what?
minus.
Minus, because, oh, giving you answer already. H2PO4 minus, because you are taking away just one proton. So that one proton will give you a -1. And then H2O, H3O plus becomes, I already given the answer, H2O, because you are taking away H plus, right? So that becomes HO, H2O, all right? Now, let me go further. What is the conjugate base for this one? Because this is an acid as well. Now, it's acting as an acid because it has a proton. So what is the conjugate base for this H2OPO4 minus?
HPO4 2 minus.
Very good. HPO4 2 minus. Why 2 minus? Because you are taking away one positive again. That becomes two negatives. All right. So what about this? What is the conjugate base for H2O?
HO minus.
OH, not OH, not HO. OH. Call it OH, OH minus. All right. So this can also go further to give us another conjugate base. What is the conjugate base for HPO4 2 minus?
PO4 3 minus.
PO4 3 minus. Excellent. That is it. PO4 3 minus. You can see that this is a phosphate. If you check your formula sheet, phosphate has PO4 3 minus charge. So this is how to get your conjugate base and conjugate acid. All right. So a polyprotic is an acid with more than one hydrogen ion. So example is H3PO4, H3O plus, H2SO4, H3PO3, all those acid that has more than one proton are called polyprotic. If it is only one proton, you call it monoprotic, like HCl, HF, HBr, they are all monoprotic, 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 because you have one proton, monoprotic. But this one is polyprotic because it has more than one hydrogen ion. Any question on this? All right, conjugate base. Give the conjugate acid for each of the following. What is the conjugate acid for HBr? Amy, you've not been talking.
HBr.
All right, somebody gave the answer HBr. Very good. You just had H plus. All right, Amy, number two. HSO4 minus. What is the conjugate acid for that?
I just did number one as well.
Sorry?
I was the one that gave number one.
Okay. Sorry, I didn't know. I didn't. Maybe a bad memory of your voice. I should remember your voice. I don't know why. Okay, number two. Let me call somebody that's not been speaking. Who's that? Let me see. Who? Ethan, you're here today. Ethan, what is the conjugate acid for HSO4 minus? Ethan, Sean, you don't have time. Sean,
Is it H2SO4?
H2SO4. Thank you. Remember, you are adding H plus. So that H plus will cancel the minus. Remember that. All right. Raymond, number three, CO3 2 minus. What is the conjugate acid for that?
HCO3 minus.
Very good. HCO3 minus, only one minus because that H plus has taken away the minus sign. All right, that is how I'm going to end this section of the lesson. So let me stop my recording.